Thank you for joining another Quod Expert Talk. My name's Medan Gabbay. I'm CEO of Quod Financial, a provider of technology to financial services specializing in order and execution management. And we've recently released a new product called Unity, which is an architecture layer for interconnecting applications in financial services, and in particular offering a normalization layer that enables AI in your organization. I'm joined by Ivan, Chief Revenue Officer of Boltzbit, a specialist provider of technology and architecture services for AI and custom LLM. Talk to us a little bit about your services.
Thank you, Medan. Pleasure to be here, and absolute pleasure to be partnering with Quod and be part of the Unity ecosystem, empowering AI and democratizing adoption of the latest LLM technology within the financial services. Boltzbit is an AI infrastructure provider for custom large language model solutions. And as a horizontal tech player, we service multiple industry verticals and domains. Current focus is on the financial services, working with buy-side, sell-side data vendors, and also technology providers such as Quod.
In the industry, AI is a hot topic. Everyone's thinking about how they can use it, but I think generally, adoption and practical use cases has been a real challenge. With Quod, we realized that releasing a product, the Unity architecture, would allow customers to interact with normalized data, to interact with different systems, and to bring AI more quickly into their infrastructure so that they could look at different vendors and understand how these vendors could assist their capabilities. Why I'm excited about this conversation is it's an opportunity to really have a conversation with you on how are people using AI? What do you see are the practical applications of AI in the industry? And what should our customers and our prospects and generally people in the industry be thinking about AI as a possible use case?
The challenges and the problems customers are looking to solve with the new wave of technology are pretty much the same that we've been trying to solve from a fintech SaaS perspective. And those around data aggregation, those around accessing data faster in a more efficient way, and those around optimizing decision-making. If it's execution or being able to select your brokers or venue or any type of decision and prediction capabilities on the back of the data you have.
When I think about AI, I think back to the internet. And when the internet came, everything changed. And everything changed really quickly. In all of the industries, we could see the impact, we could see the change. 2 or 3 years ago, when AI was really picking up pace, I think everyone thought everything's going to change again. And certainly in some areas it has. Access to open models and the ability to write documents and make changes, that's certainly impacted our lives in a very meaningful way, but not a fundamental way. And I think that's an interesting opening question. As someone who really works in this industry, you're building models, you're seeing what's available in the market, you're trying to design solutions. Why hasn't AI taken off in financial services in a way that maybe we all thought it would a couple of years ago?
My short answer to this question is that people do not know yet how to work with the technology, what to use it for, how to justify the ROI, if there is any ROI at the moment to be realized, because very few of the AI use cases are actually hitting production. People are still in POC stage, probably 99% of everyone we're talking to and we're interacting with is still experimenting. And the technology is so novel, and it requires a very high level of expertise to be able to adapt it to your data and to the business and make it work in a production environment. So we will see more examples of customers, especially in the financial services, reaping the benefits of the technology. But until those benefits hit the bottom line and you can actually report it in your financial statements as a profit or loss retention or loss prevention, that would not be as apparent.
So there's a few things to unpick there. I'm kind of curious on the way that you're seeing POCs evolve. But even before we address that, you keep saying the technology. That's obviously a broad statement in the context of AI. So when you say technology in AI, what are you really talking about?
I'm referring to generative AI and in particular large language models. And we can take it a step down and just call them transformers. So it's the new machine learning framework that allows for a model to efficiently predict what is the next sequence of words or numbers and generate content on the back of that.
So this is really the transition when we talk about AI, because machine learning and automation have existed. I mean, we've certainly had automation for 10 years in our product, where you're building rules and making decisions based on conditions. This ties in a little bit to the POCs. So where are you seeing POCs? How are they evolving around this predictive technology? What's the focus? What are people trying to run their POCs around?
I'll take a step back, and before we define what a POC looks like, we should differentiate between personal productivity usage of large language models and enterprise usage of large language models. I would say the personal efficiency gains on a single user level are unquestionable and undeniable. People use Copilot, people use ChatGPT to brainstorm, to access information, to search, and to interact with data that has not been possible before. Now, enterprise applications require a different framework and different product layer to be able to benefit from the underlying technology. And that mostly revolves around accessing data, interrogating data, and using data to make informed decisions, be it in training or in decision-making capabilities. The POC we see on enterprise levels are mostly centered around capturing and normalizing and engaging data. We're not at the level where customers are substituting traditional machine learning models with the new AI technology, but preparing for that state in the future where they're able to do so by aggregating and normalizing the data, being able to access the data from a single central point, which speaks back to what you guys are developing with Unity and the ability to provide that single aggregated layer to customers from a single connectivity point. And this will be critical.
I agree with the data challenge. And we've seen the same thing as a business. We're predominantly a development house. We've got 200 engineers, and the individual productivity gain is exactly the benefit that we've seen. It's how can one person in the organization do more, test more, write more code, better quality. So we've had a number of initiatives ourselves around producing more product. Ultimately, that makes us a better company. The data challenge is very interesting. Being able to deliver unified data has been a goal of the industry across all asset classes, across all providers. How is your product going to take advantage of this new normalized data? What are the first applications that you see your models delivering beyond that initial POC failure point that people are having around data?
Well, first of all, we exist in the very initial stage of clients working with data. The solutions that Boltzbit customizes and develops for clients is around the extraction and the normalization of the data, because that on its own is a very challenging process. Once the data is normalized and sits in a location that can be very easily accessed, we provide solutions that allow customers to query that data via natural language, translating that into Python code or SQL queries, and resurface the data in a way that suits the business at the current point in time. Very frequently, and probably in your line of business, you see customers hard coding reports, performing data retrieval functions that take a very long time to be able to deliver the certain data when you need to make a decision in the next 10 seconds. You don't have time to go and request a data point from someone to put in a report. You want to be able to just go and ask your system and resurface it in a format that would make you more capable of making a decision on the spot. And this is, I think, the key point that a lot of customers and enterprise clients are underestimating, is the speed of data retrieval.
So the initial benefits that you're seeing are people's ability to interact directly with data in the organization. That's the first and most practical use case. Natural language querying of information, and then potentially linking that into trader workflows, being able to ask questions like, when was this instrument last traded, or who might be interested in executing this particular instrument or interrogating P&L. It's those types of interactions that you're seeing as the phase one at the front line of the trader's workflow.
That is correct. And the key here for enterprise success is the ability to trace the information that is being presented to you by the solution back to the source. You need to be able, as a human, to verify if this piece of information is legitimate, where it's coming from, and why you are being presented with this type of information. And this is where features of large language models, such as chain of thought and reasoning capabilities, come into play, so that the human expert can interrogate the model, how it approaches the problem that it's just been presented with. And having the ability to also tinker with the chain of thought and the reasoning of the model presents probably the best opportunity where human feedback is embedded in the models and make those models improve, and they become better with time as more humans interact.
That's really interesting, because it's that fear of the lack of accountability of the model. You know, if you're asking someone to give you information or give you a decision, the fundamental human accountability of, I might get fired if this information is wrong, provides an impetus and provides a level of interaction with that data that you can rely on it. Where if you're going to a model and asking it a question, it doesn't fundamentally care if that information is right or wrong. So you need to know, where has it come from? Is it hallucinating? How is it being delivered? And certainly, how can I make a judgment on whether it's obtained it correctly? So part of what you're delivering as a platform when you're addressing data is that reasoning, the accountability, and the human optimization of that data after it's been delivered.
I would define it as a complete data lineage. This is why the involvement of the models from a very early stage of the life cycle of the data is from the extraction, because the model then understands the source of the information. Where is that information coming from? How does the source look like? Where can I access the data in a much more easy and efficient way? If you train the models to understand the source, they will hallucinate less, and naturally you'll be able to rely on them more and more and more. It's not sufficient to provide the references to the sources where the data comes from. The model needs to present and resurface to you the exact location in the source where the piece of data has been picked from. If it's a document of unstructured data, if it's another database, if it's a website, if it's another internal tooling that provides you that information, you should have the full traceability of that data, not only for yourself, but also for your customers, right? You need to fulfill your fiduciary responsibilities to provide security and trust in the products you're delivering to customers, which you do very well and you continue doing.
Okay, and it's a really interesting interplay that is the foundation of the partnership between our businesses. The first stage problem, whether you're a buy side or a sell side, is I have multiple systems. I have multiple data sets stored in different ways across different asset classes with different origins, and I need the integration to bring those products together. I need it in real time. I need them unified. And this is the solution that we built for ourselves in our own EMS, the Unity product, which is I need a layer, an architectural layer that interconnects these systems and presents one single interface for accessing data, triggering trade workflows, understanding P&L inside of my business. Layer 2 is, once I've got that information, once it's available, how can I build custom AI models? And then how can I trust them to interrogate that data and give me real-time views? That's the evolution beyond machine learning. And it's these two products that we're offering together as two separate layers to deliver that complete service of data availability, systems access and interoperability, and then also data interrogation, which is the key first stage of any successful AI project.
You're making a very important point by stating the true problem of the current technology adoption and implementation, right? And that's the data accessibility. Data preparedness and data cleanliness is an issue, but it's something that can be solved with AI and with models that can clean data, label data, and prepare the data for consumption. But the infrastructure layer, which in majority of cases in the fintech domain and also like amongst financial services is so proprietary and so specific to the workflow, to the systems, to the clients, is not something that large language models currently available have been trained on. And they never be trained on because this is proprietary information that you will never feed to a cloud model. But this is something that you have access to as Quod as a solutions provider, and your clients have access to. Once you train the model to understand what those messages, what those connectivity points and data looks like, this is when you start really receiving the performance of the models that everyone expects to see.
So what do you see as the phase two? We've touched on the typical proof of concept. That would be real-time information available to traders for them to use in their trading workflows. But I guess the benefit of that is it's information to the trader, but they're still ultimately making the decisions around actions.
That is correct.
So what do you see as phase two, the evolution beyond trader information? Is there any kind of actions that you're looking at implementing?
Phase two, I'll call it any future application of the technology, in my opinion, is around decision making. And this is where we get into the machine learning space and start figuring out what can the transformer technology or the large language models do to supercharge decision making. Think of it as a trader's Copilot or analyst Copilot in any type of a user/Copilot application for that. And that Copilot essentially exists in your system. It doesn't have to make decisions automatically on behalf of customers, but aids the decision-making process. What humans are very good at is making decisions on the data they have presented, but what they're not very good at is extracting patterns from very large sets of data. Our brains are incapable of doing that compared to a large language model that has billions and billions and billions of parameters and neurons in its network and can look across data simultaneously in real time. And this is where we can really harness the power of the parallel computation capabilities of the new models to be able to infer features from the data and to be able to give us better predictability irrespective of data type.
I guess there's two sides to that. There's identifying patterns. There's also eliminating bias. Because as much as you might think as a trader that you don't have any bias in your decisions, it will always be there. As a human being, there's always an element of bias. So using that information to show you that certain actions that you're doing have a negative impact that you're not perceiving, while at the same time giving you informed pattern recognition of ways that your actions can improve the quality of your trading. It's those two pieces. Fewer negatives, more positive opportunities that the AI can deliver directly into the workflow that you're executing.
I don't think bias is unnecessarily a bad thing as long as you know how to manage it. And by that, I'll give you an example. We spoke to a sell-side shop recently who wanted to use the technology to automate market making in fixed income, in equity, that doesn't matter. And the ability for the model to react as the trader is very important, which means you need to be able to distill the trader's behavior into the model so that if the trader, let's say, leaves the firm or goes on holidays, you can turn the algorithmic price making and the customer on the other side will not feel a difference as to how they're being treated or how the company calls back to them because you're distilling the behavior of the trader in the model. So it can mimic what the market maker is doing on the desk. And therefore also distilling the bias in how the trader operates because this is something that customers of the institution might value and come in order to do more business. So it's a two-sided argument. The most important thing is for enterprise to be in control. Do we want more bias or do we want less bias in the current context of our business and how we're operating?
So one of the things you spoke about in your intro was the idea of AI needing to prove P&L. It needs to show an ROI. So where are you first seeing ROI being identified in the businesses that are using your technology?
As I mentioned initially, data extraction is the first part of the life cycle of implementation of those models, and this is where we see most of the gains, is the reduction of human resources needed to process data. Very often we see customers reducing manual data entry time spent by more than 80 to 90%. And this is huge because you at some point might need to engage human capital from other divisions of your business just to do something that's not critical to the core job, like processing data. If you can eliminate that, you're already saving in time and you're saving on human resources that you need to pay for. An example might be processing new issues data, which comes in very unstructured format, and everyone needs to know what's going on in the market and what is the latest securities that are being issued. Processing claims in the insurance business, not very much applicable to the financial sector, but it's still relevant. Private credit documentation. Take the entire KYC process as an example. It's so laborious, and it's essentially a system that is designed to just go and tick several boxes. Why do you need humans to do that? No human likes doing that job. You need humans to orchestrate the system, check and make sure everything works as designed, but you don't need them to be data clerks entering information from a PDF into a system. You can completely automate that, and thus saving like large amounts of money spent on human labor.
So perhaps if we go back to my earlier point where I was trying to compare the current universe of AI against the influx of change that came with the internet. Mm-hmm. I think one of the key messages that you have is, I said it didn't seem as transformative as the internet was in the initial years. But even looking at comparing fossil fuels to electric vehicles, on the road, you're not immediately seeing the difference. But the entire architecture of how you manage data, the entire architecture of costs inside your business can be transformed through this initial phase one use of AI.
That's a good way of thinking about it, and I agree with you. We have not changed our ways of how we do things. Compared to the internet, we were buying books in the store, and all of a sudden you could buy books online. So that's a big shift. I think what's happening is we're seeing increase in the speed of data acquisition, in the speed of accessing data and insights, and that will lead to something else, which I don't know what it will be, but it's the democratization of the usage of technology and the engagement of data in the processes that is really happening right now because of AI and because of generative AI and how customers implement those.
Let's talk about models. Internally, we've obviously implemented many of the traditional models that we've seen. And actually, one of our challenges in engineering was people cycling through Gemini and Claude and Mistral and OpenAI and trying to find the right model, the right fit for a particular purpose. But in your case, and certainly one of the fears in financial services is, how do I make use of these models? Is my data safe? And also critically, how do I customize it? How do I add learning into the selection of a model? So how at Boltzbit have you addressed this?
Model ownership is critical for enterprise applications. And let's not kid ourselves by thinking that a generic model which is supposed to represent AGI, or whatever they call it these days, can solve all the enterprise problems. Even the simplest of problems on the enterprise side is so private, so niche, that big models have not seen the data for it. So that's a challenge. And the models in the cloud or in off the shelf are aligned with the cloud provider and the model provider, not with the customer, because they do not own the IP of that model. Now, the key for successfully implementing something that actually works is a model that is customized and trained on your private data and on your private workflows. And this is where Boltzbit comes into play, providing the infrastructure layer for customers to be able to distill, customize, train, fine-tune their own private models on their private data and own the model weights. So the resulting model of the interaction between ourselves and the client is the customer IP.
So as I understand this interaction, you're still using LLMs that are publicly available. You're using
Correct.
that technology. But what you're enabling people to do is to bring one or multiple LLMs in-house. And you're adding a layer of decision-making and IP that allows custom behaviors, custom learning from that LLM. So the power of the intelligence, which you're then allowing your technology to customize to their specific workflows.
That is correct. We take away the most costly, complicated, and burdensome exercise from the customer, which is the model pre-training and ongoing fine-tuning. And this saves millions of dollars to each customer interacting with the technology. We're essentially delivering a no-code solution for model customization.
And those underlying models can be changed at any time.
That is correct. We work with open source models. It's the foundation of what we do and what we architect. And the open source community is very active, it's very dynamic. Model, I would say, leaders change all the time. This week might be Gemini, next week might be OpenAI, as they have open source models now. Week after might be Llama, then you have Q. And the competition is fierce, and everyone's trying to beat the benchmarks all the time. It's irrelevant to the business. I think taking a step back, and I would say this, the open source models and any generic LLM out there on the market is hitting a scaling wall. They've been trained to the maximum permissible amounts of data that we have available in the public domain, and that's the entire internet. You cannot squeeze any more performance or semantic capability out of these models anymore unless you start training them on private data in private workflows. And this is why custom large language model solutions, custom models and architectures play a pivotal role in the success of the adoption of the technology by businesses.
So as a business leader, I see the decisions that people are trying to make have an element of fear over which model do I choose? Which AI provider do I choose? They may not even be there in 6 months. The model may not be the leading model in 6 months. And one of the challenges we were trying to solve with Unity was if we can speed up the go-to-market by pre-creating all of those integrations in the architecture, then it would be much easier to step new providers in, to step new technologies in. You lose the overhead of having to integrate and normalize each provider into your data sets. So if that architecture element is solved, now what you're looking to do is to choose models, to bring in providers. And what Boltzbit does is you give that ability to fully customize the behavior, but have that customization layer independent of the models that you're using. So you can change models over time, but retain the customizations, retain the training on your internal data.
That is correct.
That's so powerful.
And the only reason why we might consider changing or swapping the underlying open source model is if there are any benefits in the new architecture, the new semantic capability of that model. And clients can choose whatever open source core they want to use. Of course, we can recommend for the specific use case, but anyone is free to choose. Because it becomes irrelevant at the point where you fine-tune on your business workflows in your data. It does not matter. If your model is performing at 99% accuracy, why would you even consider swapping that out?
Yeah.
It doesn't make any sense. So what we do is essentially what you guys are doing on the infrastructure, data integration and communication side, where you can swap best systems in and out. We're doing the same with our infrastructure and architecture, where we can just swap the latest, greatest open source model and architect around it. Our IP is in the architecture around it, not in the model itself. We're not a large language model company or provider like OpenAI is and Gemini and Meta, but it's the architecture around it that makes the difference and make the technology really work.
So let's look at some other hot topics. Something that comes up a lot in conversation, and certainly I see it as I read and do research into AI personally, is the idea of the MCP layer. Can you just tell us a little bit about your view on MCP?
Well, what the MCP is a unified communication protocol between your AI agent, or let's not use the word agent, just call it a fine-tuned model, and other toolings and information sources and programs you might have at your disposal. We've been dealing with MCP type of solutions in the financial services industry for a very long time, and those are just normalized APIs or certain standardized protocol of communication between systems, for example, FIX. So it's nothing new to me. And I think MCP is still very overhyped and clunky because it's not mature yet to the extent that we've seen APIs and standard protocols maturing in the financial services domain. MCP is needed when you're working with a generic model that might not know when and how to access the data that it currently needs. However, if you have a model fully trained and adapted to your business workflows and data, MCPs are not always needed and become, I wouldn't call it obsolete at some point, but become unnecessary and might be additional overhead that you don't want to deal with.
So I guess one of the distinctions we always have in financial services is it's a highly specialized industry, which is targeting highly specialized applications. The real challenge isn't how can I have a generic interface that I'm facing against generic models. It's how can I have unified custom interfaces facing custom models. I need access to my own data, my own training, my own IP, and I want to be able to apply it to a normalized integration layer where I can talk to my different trading applications, but in a very specific way. So to a certain extent, our view of MCP is the Unity layer itself, the single API that we're providing, replaces the need for any kind of generic interface because actually it's delivering all available data in a normalized source in real time, including historical data, directly to your custom application, to your custom LLM. And that's really, again, the two sides of the challenge. One of them is, how do I find a product that integrates everything? And the second one is, how do I build a model that can do my actions and can understand my private data in response to accessing that single API?
Right. Think about what we're doing between Boltzbit and Quod Unity. We're creating two unified layers, one for data access and normalization, and the other one for directly intelligence. So we overlay the intelligence layer on top of Unity, benefit from the single connectivity point of the data and being able to perform all the functions the business wants to perform. Now, MCP will be useful if you have an internal system that gives access to people externally to query and interact with. Considering that in most cases, our clients prefer to deploy on-premise, both Unity and Boltzbit, there's no need for that external connection if we have a certified layer between the intelligence piece and the data aggregation and infrastructure service. So that negates the usage of MCP solutions because we have something much more performant.
Boltzbit and Unity, one out-of-the-box, fully functional AI and data architecture.
That is correct.
I took Unity and Boltzbit tomorrow. What would be the three first use cases if I'm in a brokerage or a buy side and I took Boltzbit and Unity tomorrow? What would be my three first use cases that I might implement?
Number one use case would be around data aggregation. And that's not only consuming data from Unity, but also normalizing and feeding data back to Unity from the markets or from any unstructured sources that clients have at their disposal. Number two is being able to create reports for your clients, for your brokers on the fly using natural language and visualize those on the spot. And number three would be around decision making. And one example I can give you is what customers in fixed income do, and it's probably the biggest headache, is to decide where to trade and who to trade with. That information is usually warehoused in traders' heads, and this is what they get paid money for, to know where to go for the liquidity. But they would like to also offer a Copilot that is able to recommend. So broker selection, venue selection with a custom large language model that essentially performs a machine learning function to output a recommended avenue of execution.
This is one of the key reasons that when we released Unity as an architecture, we actually included the pre-trade automation elements of the Quod trading application inside the Unity layer. So it's possible to build rules, it's possible to build automation, it's possible to weight decisions and manage your order flow using an AI layer. Interacting directly with a rules-based automation engine, which we've had for years. But the challenge has always been getting people to input those rules, to get from people's experience, from their biases, from their knowledge base, to write those rules and to codify them. And the key benefit, I guess, of a custom AI model is you can train that to the preferences of the business, to the preferences of the individual trader, and have them apply that automation directly into the workflows of your existing systems without having to change OMS or EMS.
You can just talk to the model and let it translate what you just gave it as feedback into code or into feature or into a rule. Of course, with some supervision on top of that, but the access to human experts' knowledge has been unlocked. And that's because of the technology we provide on top of the customization of those large language models, being able to take the feedback immediately and improve the model on the spot without waiting for the new version of the model to come in the next 6 months. You want models to adapt fast, you want them to react on your data and on user feedback so that you're in tune with the market and you can actually perform. Otherwise, you work with stale, outdated models that have no knowledge of any information or feedback they've received.
Last question. Where is this going? We've all heard about AGI already, but that didn't bring AGI. It's apparently around the corner. Where is this going?
I would advise against using the term AGI in the context of large language models and transformers. It's more of a hype word. But if I had to make a prediction and express an opinion on that, is the future of AI is in private data, privately trained models, private architectures, utilizing the largest data set that currently exists, which is way bigger than, much bigger than the entirety of the internet, which is the enterprise data and the data that sits in humans' heads, right? It's the human expert knowledge, which enterprises will find a way to distill into the models. In order for them to be able to do that, you need a mechanism that allows the models to adapt to that knowledge very quickly in real time. And this is where learning becomes critical. I'm referring to model learning. And this is where fine-tuning in real time becomes very critical.
So the future of AI is really about bringing these generic and highly optimized models into the workplace without risking IP.
That is correct.
And enabling local training, enabling every individual who's been working in your organization and working in the industry for years to distill their knowledge locally into the application, but without losing that IP, without risking that loss of information. And you're effectively gaining the combined knowledge of all of these open models with the expertise of your organization and the personality of your organization. As you said, correct. Those biases form part of that.
What I would like to see in a few years' time is people looking back at 2025 and questions like, wow, do you remember back in the days we had static models? Like, how crazy was that, right? I mean, why wouldn't the model learn in real time? Why wouldn't it adapt to the knowledge as it sees it? Same as with humans. I give you some information right now. We're having a conversation. You would retain that information, learn something new, and build some new neural connections in your brain. Same with hiring an intern, right? They don't know much about the business, but you expect them in 3 months' time to learn and adapt. So the question here to the human and to the model is, how quickly can you learn? How fast can you become smarter? And this is what we'll see in the future, is the technology becoming capable of producing new levels of accuracy and smartness and intelligence on the fly as it's just new information coming in.
And applying that information. In the context of the business, in the context of the knowledge of the business.
I mean, think about trading. Can you apply current LLMs in trading applications? No, because they don't react on the information coming in. Markets can change in a split of a second, in minutes.
So Boltzbit solves that.
That's what we aim for.
Thank you very much for joining us at another Quod Expert Talk. Here we've heard a little bit about the future of AI, how to solve your immediate problems, and the technologies that are available between Boltzbit and Quod Unity for really moving the needle on getting an AI project in production right now.
Thank you for inviting me. That's been a pleasure, and I hope we'll be able to do it again. The conversation was very important for us to be able to contextualize where the technology sits and what we're able to do with it in the financial services domain.
Okay, so let's go train some AI.
Fine-tuning time. Let's do it.